Where is everybody? That simple question, asked by physicist Enrico Fermi over a casual lunch, echoes across our silent, star-filled cosmos. The universe is unimaginably vast, with billions of planets that could support life, yet we hear nothing but an endless quiet. This is the Fermi paradox, the profound contradiction between the high probability of alien civilizations and their complete absence. Today, we are revisiting this cosmic mystery with revolutionary ideas that turn old assumptions upside down. By the end of this journey, you will discover a collection of startling new solutions to this ancient silence, from hidden dimensions and galactic hibernation to the terrifying possibility that we are being deliberately avoided. We will explore whether advanced beings have evolved beyond our perception, if the universe itself is a carefully constructed illusion, or if a deadly filter awaits us all. Are we truly alone in the universe, or is the truth far stranger than we ever imagined? Think of the universe as an endless, dark ocean dotted with islands of light. We are adrift on a tiny raft, scanning the horizon for any sign of another vessel, a beacon, a ripple in the water made by another traveler. Yet the sea remains perfectly still, a silent and empty expanse stretching into infinity. This profound silence is the heart of the Fermi paradox. It began not in a grand lecture hall, but over a casual lunch in the summer of 1950. Physicist Enrico Fermi, discussing flying saucers with his colleagues, suddenly asked a question that would echo for decades. Where is everybody? The sheer simplicity of the question belies its immense weight. The contradiction is staggering. Our galaxy alone contains hundreds of billions of stars, and many of these are orbited by planets in the habitable zone, the so-called Goldilocks region where conditions are just right for liquid water and potentially life. Given the sheer number of opportunities, the universe should be teeming with civilizations. The silence we hear is, therefore, deeply unsettling. Scientists like Frank Drake tried to quantify this expectation. He created the Drake equation, a way to estimate the number of detectable civilizations in our galaxy. The equation multiplies a series of factors. It starts with the rate of star formation, then the fraction of those stars with planets. Next, it considers the number of planets that could support life, the fraction where life actually emerges, the fraction where that life becomes intelligent, the fraction that develops technology to broadcast its existence, and finally, the length of time such a civilization lasts. Each factor seemed, to many early researchers, to point toward a galaxy filled with voices. Carl Sagan famously used optimistic estimates to suggest there could be millions of advanced societies. Yet when we point our most powerful telescopes and radio dishes at the cosmos, we hear nothing but the natural background hum of the universe, so the question remains, a haunting whisper in the void. Are we truly the only ones to have gazed up at the stars and wondered, or is there something else at play, a cosmic reason for the silence that we have not yet understood? But what if the very foundation of our cosmic hope is flawed? Think of the Drake equation as a magnificent house built upon uncertain ground, a structure designed to estimate the number of civilizations we might talk to, but one that relies on pillars we can barely see. We have been staring at this beautiful blueprint for decades, convinced it points to a crowded galaxy, yet we never stopped to ask if the ground beneath it was solid. Each variable in this equation is a guess, and new research suggests our guesses may have been wildly optimistic. Let us walk through this house of cards. The equation begins with factors we can now observe with some confidence, like the rate of star formation and the fraction of stars with planets. These steps feel secure. But then we move into the shadows. We reach the step for the fraction of planets where life actually emerges, a process called abiogenesis. Here, the foundation cracks. We have only one data point, Earth, and we have no idea if the spark of life is a common cosmic event or a miraculous fluke. As one contemporary astrophysicist argues, the transition from chemistry to biology might be the universe's greatest bottleneck, an event so improbable that it has only happened once in our entire cosmic neighborhood. The next variable is even shakier, the fraction of life that becomes intelligent. Does life always evolve towards self-awareness and tool use, or are we a bizarre evolutionary accident? Then comes the most troubling critique of all, the final variable, the lifetime of a communicative civilization. This is the pillar that may be collapsing under its own weight. The equation assumes that once a species develops radio technology, it might broadcast for thousands or even millions of years. But what if the average lifespan of a technological civilization is not millennia, but merely centuries? Consider Earth's own narrow window. We have only been broadcasting our presence for about 100 years, a blink in cosmic time. Already, we face existential threats from nuclear war, climate change, or engineered pandemics, challenges that could silence us forever. This suggests a terrifying possibility that intelligent life may contain the seeds of its own destruction, rising quickly only to burn out in a flash. The great filter might not be behind us in the difficulty of creating life, but ahead of us in the near impossibility of surviving our own technology. So when we plug these new, more pessimistic numbers into the equation, the result is a galaxy that is not teeming with voices, but one that is hauntingly, profoundly silent. Have our cosmic calculations been a work of hope rather than reality, leading us to expect company in a universe where, in the end, we might truly be alone? A narrow mountain pass cuts through the highest peaks, a treacherous path where countless travelers have begun the journey, but only a handful emerge on the other side. This is the great filter, a cosmic bottleneck so challenging that it stops almost every civilization in its tracks, leaving the universe silent. The hypothesis suggests that somewhere in the grand sequence of evolution, from stardust to spacefaring intelligence, there lies a barrier of such immense difficulty that nearly everything fails. This single, formidable obstacle could explain the void we see. Philosopher Nick Bostrom has framed this with chilling clarity, arguing that the silence of the cosmos is either very good or very bad news for humanity. If the filter is behind us, if the step from non-life to life or from simple cells to complex intelligence is the universe's rarest miracle, then we are the lucky ones who made it through, destined to find an empty galaxy waiting for us. But if the filter is still ahead of us, then our technological adolescence may be the very thing that dooms us, and the silence we hear is the sound of every other civilization that reached this point and then vanished. So where could this filter lie? Perhaps it was the very origin of life, that first spark in the primordial soup, a chemical fluke that almost never repeats. Or maybe it was the leap to multicellular organisms, a biological innovation that took billions of years to occur on Earth. But the most terrifying possibility is that the filter is our own future. The development of advanced technology, from artificial intelligence to nuclear weapons, might create challenges so profound that no species has ever survived them. The same tools that allow us to shout our name into the cosmos could be the ones that ensure our whisper is the last. The great filter forces us to look in the mirror and ask a harrowing question. Is our civilization's brief, bright flash just the prelude to an inevitable extinction? And is the eternal silence we observe not a mystery but a warning? A vast protected wilderness stretches out under a watchful sky, a place where animals roam free, unaware of the silent observers beyond the fence. This is the essence of the zoo hypothesis, a startling solution to the Fermi paradox that suggests we are not alone, but living in a cosmic sanctuary. According to this idea, advanced extraterrestrial civilizations are fully aware of our existence, but they have chosen to place Earth under a form of quarantine, observing our development from a distance without ever revealing themselves. Proponents like radio astronomer John A. Ball argued that our planet could be part of a galactic zoo, a controlled environment for study, or perhaps even a protected cultural reserve. The motives for such a policy are as profound as they are varied. It could be rooted in a strict ethical code, a non-interference directive not unlike the Prime Directive from Star Trek, where superior beings vow not to influence the natural evolution of younger species. They might fear that even a single hello could irrevocably shatter our cultural and scientific trajectory, contaminating a unique experiment in societal development. Think of it like anthropologists studying an uncontacted tribe in the deepest rainforest. The researchers remain hidden not out of malice, but from a desire to preserve the tribe's way of life, to learn from its natural state without imposing their own presence. The silence we experience, then, is not an absence but a deliberate and respectful choice. So this forces a deeply personal question upon us. If we are the subjects of this grand cosmic observation, would we truly want the curtain to be pulled back? Would the knowledge that we are being watched be a source of wonder or a terrifying loss of our own autonomy? This idea of intentional silence opens the door to even more unsettling possibilities, where the reason for the quiet is not protection, but something far more cautious. The idea of a cosmic zoo is unsettling, but it relies on a universe that is fundamentally real. What if even that assumption is wrong? Your senses tell you that the stars above are ancient, distant suns, that the universe is a vast physical expanse stretching back billions of years. But what if every piece of that evidence, from the light of distant galaxies to the very laws of physics, is an elaborate fabrication? This is the Planetarium Hypothesis, a mind-bending proposal from author Stephen Baxter. It suggests that our entire observable universe is not a wilderness, but a sophisticated simulation, a planetarium dome of unimaginable complexity constructed by a super-intelligent civilization. We are not merely being observed from behind a fence, we are living inside the exhibit itself. The silence we perceive makes perfect sense under this model, because there are no other real civilizations out there to contact. Every potential signal, every tantalizing exoplanet, is just part of the programmed scenery, designed to give us the illusion of a vast, empty cosmos and keep us contained within our own celestial terrarium. Philosopher Nick Bostrom's famous simulation argument lends weight to this terrifying thought experiment. He posits that if a civilization could ever reach a post-human stage capable of running vast ancestor simulations, then the number of simulated minds would vastly outnumber the real ones. Statistically, we are more likely to be one of those simulated beings than a creature of base reality. The technological power required for such a feat is beyond our comprehension, but not necessarily impossible for a society millions of years more advanced than our own. For them, harnessing the energy of entire stars to power a computational substrate could be trivial. They might run countless such simulations for research, for entertainment, or for reasons we cannot even fathom. This idea forces us to confront the nature of reality itself. If we are in a simulation, then the Fermi paradox is not a mystery of deep space, but a feature of the code. The silence is programmed, so does that make the great quiet less mysterious or somehow more profound? It transforms our search for aliens from a scan of the heavens into a search for glitches in the matrix, for evidence of the architects who built our cage of stars. And if the universe itself is an illusion, what other truths have we gotten completely wrong? A caterpillar vanishes into its chrysalis, and what emerges is no longer a ground-crawling insect, but a butterfly, a creature of the air that its former self could never comprehend. This transformation is the heart of the Transcension Hypothesis, a radical idea suggesting that advanced civilizations do not die out, but simply evolve into states that are utterly invisible to us. They have not vanished, they have transcended. Futurist John Smart proposes that intelligent life does not endlessly expand across the stars, but instead turns inward, following a path of ever-increasing miniaturization and efficiency. The ultimate goal is not to conquer outer space, but to explore the infinite frontiers of inner space, perhaps by uploading their consciousness into vast digital realities, or migrating into dimensions of existence our senses cannot access. Think of how a neutrino passes through your body by the trillions every second, completely unnoticed and unfelt. These hidden civilizations could be all around us, their activities and energy used so advanced that they leave no trace we are equipped to notice. They might harness the power of black holes, converting entire stars into computational energy for purposes we cannot fathom, their signatures lost in the background hum of the cosmos. So the profound silence we observe may be the most deceptive kind of signal. It is not a sign of emptiness, but of a universe teeming with life that has simply moved on to a different phase of existence. This forces a deeply humbling question. Are our methods of searching, our radio telescopes and optical arrays, merely listening for the chatter of other caterpillars, completely missing the silent flight of the butterflies all around us? The forest is infinitely dark, and every hunter moves with a breath held tight, knowing that any sound, any flicker of light could draw a fatal shot from an unseen predator. This is not a woodland on Earth, but a metaphor for the cosmos itself, a chilling explanation for the silence known as the dark forest theory. Popularized by author Liu Cixin in his science fiction, this idea suggests that the universe is not empty, but crowded with civilizations that have all chosen to hide, cloaking their presence out of primal, rational fear. The logic is as cold as the vacuum of space and rests on a few brutal axioms. First, survival is the primary need of any civilization. Second, resources in the universe are finite. And third, it is impossible to know the intentions of another species you have never met. Combine these truths and a terrifying picture emerges. Any other life form you encounter could see you as a competitor for the same scarce resources, or as a potential threat to be eliminated before it eliminates you. In such a universe, the only safe strategy is to remain absolutely silent, to never reveal your location, because the first civilization to broadcast a hello might be the first to receive a preemptive strike. Scientists applying game theory to this cosmic sociology point out that the stakes are unimaginably high. With distances between stars so vast, communication is impossibly slow, making trust building a practical impossibility. You could never be sure if a friendly message was a genuine greeting or a deceptive lure. The safest, most rational assumption is to treat every other potential civilization as a direct existential threat. This logic transforms our search for extraterrestrial intelligence, or SETI, from a hopeful endeavor into a potentially perilous one. If the dark forest is real, then listening passively is the only safe activity. Actively transmitting signals, as we have done with projects like the Arecibo message, could be akin to shouting in that dark woods, announcing our location to every hunter in the galaxy. We have no idea what kind of weapons a civilization millions of years more advanced might possess, or what they would consider a necessary precaution. The Cold War here on Earth offers a stark, human-scale analogy. For decades, two superpowers lived in a state of mutual assured destruction, their fingers poised over the nuclear button, not out of a desire for conflict, but from the paralyzing fear that the other side might strike first. The entire planet held its breath, trapped in a silence born not of peace but of terror. The dark forest theory suggests this same state of brinkmanship is playing out on a galactic scale and has been for billions of years. The silence we hear is not emptiness. It is the sound of countless civilizations holding their breath, hiding in the undergrowth, praying not to be found. So this forces a deeply unsettling question upon us, one that reframes our entire place in the cosmos. Knowing the potential risks, would you be the one to stand up and announce your presence in a forest where you cannot see the other hunters, but you know they are there, listening and waiting? A bear sleeps soundly through the long, cold winter, its metabolism slowed to a crawl to preserve precious energy until spring returns. Now, expand that image to a cosmic scale, where entire civilizations might be in a state of profound slumber, not through the seasons but across billions of years. This is the Aestivation Hypothesis, a solution proposing that advanced aliens are not missing but simply waiting. The universe, for all its vast emptiness, is still too warm for them. Researchers like Anders Sandberg and Stuart Armstrong from Oxford's Future of Humanity Institute have crunched the numbers on a truly mind-boggling concept. The energy required for the most intensive computations, the kind a galaxy-spanning civilization might want to run, is drastically affected by temperature. Right now, the cosmic microwave background, the faint afterglow of the Big Bang, fills the universe with a warmth of about 3 degrees above absolute zero. While that sounds incredibly cold to us for a civilization thinking in terms of ultimate efficiency, it is a wasteful heat. They calculated that by waiting until the universe naturally expands and cools further, perhaps to a fraction of a degree colder, the energy savings for processing information could be astronomical. It would be like choosing to run all the world's computers not in a sweltering server room, but in the heart of a glacier where the natural cold dramatically cuts the cooling costs. So why would a species choose to hibernate for eons? Think of it as the ultimate act of strategic patience. Imagine a group of ancient farmers living in an arid land. They have seeds, they have tools, but the rain has not come. Instead of wasting their precious water reserves on a few struggling plants, they wait. They conserve their resources, they sleep through the drought, knowing that when the rains finally arrive, they can cultivate the entire valley with immense success. For an advanced civilization, the resource is not water, but compatronium, the hypothetical maximum efficiency material for computation. The universe itself is their field, and they are waiting for it to cool enough to make their grand work possible. The silence we detect, then, could be the deep, collective breath of countless civilizations in Aestivation, a cosmic pause button pressed as they dream of a future harvest. This forces us to look at the cosmos not as a static stage, but as a story still in its early chapters. The universe is young, and its most ambitious players may simply be biding their time. If they are waiting for a cooler era to truly awaken, what other grand designs might be unfolding on a timescale we can barely comprehend? Our world is a vibrant jewel of blue and green, a stunning anomaly in a cosmic sea of barren rock and searing gas. This is the heart of the rare Earth hypothesis, a compelling argument that the silence we hear is not a mystery, but a simple statement of fact. We are alone because planets like ours are vanishingly rare. Paleontologist Peter Ward and astronomer Donald Brownlee, in their groundbreaking book, make a critical distinction. Microbial life, they argue, might be common throughout the cosmos. but the evolution of complex, intelligent, technological life requires a chain of perfect conditions so long and so improbable that it may have happened only once. Earth is not a typical planet, it is a cosmic jackpot winner. Consider the specific, fragile factors that had to align. We orbit a remarkably stable star, a G-type main sequence star that avoids the violent flares of smaller, more common red dwarfs. Our planet has a large moon, a rare result of a cataclysmic impact in the early solar system. This moon stabilizes our axial tilt, preventing wild climate swings that would otherwise render the planet uninhabitable for complex life. We have active plate tectonics, a global recycling system that regulates our climate and replenishes nutrients essential for life over billions of years. We sit in the galactic habitable zone, far from the deadly radiation of the crowded galactic core, and we are protected by a giant guardian, the planet Jupiter, whose immense gravity acts as a cosmic vacuum cleaner, deflecting countless comets and asteroids that would otherwise pummel our world with extinction-level events. Life on Earth demonstrates this principle perfectly. We find extremophiles, simple microbes, thriving in boiling acid, in crushing ocean depths, and frozen in ancient ice. These organisms show that life is tenacious, but not a single one of these extreme environments has produced a civilization that builds radio telescopes. They lack the stability, the energy, and the time required for the slow, delicate dance of evolution to build toward intelligence, so the profound question shifts. It is no longer where is everybody, it becomes is our planet a magnificent fluke. The rare Earth hypothesis suggests that the silence is the natural state of the universe. The cosmos may be filled with the quiet hum of bacteria, a microbial symphony, but never an orchestra, and certainly no composers. If we are the only complex mind to have ever looked up and wondered, then the responsibility that falls upon us is immeasurable. We are not just inhabitants of a planet, we are the universe's only voice, its only chance to know itself. And if we are the lone custodians of consciousness in a silent galaxy, what does that demand of us for the future? A velvet rope separates the bustling main room of an exclusive club from the quiet entrance line. Inside, ancient conversations flow between members who have known each other for millennia, while outside, newcomers wait, hoping to be judged worthy of entry. This is the Galactic Club hypothesis, a vision of the cosmos not as an empty forest, but as a vibrant, interconnected network of civilizations from which we are simply excluded. The silence we perceive is not a sign of our solitude, but of our probation. Established alien societies are out there, communicating and collaborating, but they operate under a strict and universal set of membership criteria that humanity has not yet met. What could these requirements possibly be? SETI pioneers like the late John Billingham speculated that any long-lived civilization must have overcome its own self-destructive tendencies. The primary ticket for admission, therefore, might be nothing technological but something profoundly social. Have we achieved global peace, ending war and systemic conflict? Have we solved our environmental crises, learning to live in a stable balance with our planet? Have we matured ethically, proving we can handle advanced technologies without turning them upon ourselves or others? From their perspective, a species still struggling with these fundamental challenges is simply too volatile, too dangerous to invite into the galactic community. The risks of introducing faster-than-light travel or cosmic-scale energy sources to a race still governed by tribalism and greed would be catastrophic. So we are not being ignored, we are being watched, assessed in a trial that may last for centuries. Think of a young child at a family gathering. The adults converse about complex, serious matters in the next room, their discussion a low murmur through the walls. The child can hear the voices but cannot make out the words and is certainly not invited to contribute. The adults are aware of the child, they are caring for it, but they will not bring it into the conversation until it has matured, until it can understand the nuances and responsibilities of the dialogue. Our entire civilization might be in that state of prolonged childhood. Our radio and television broadcasts, our planetary struggles, are all part of our application file, being reviewed by a committee we cannot see. This forces a moment of intense self-reflection. If the silence is a test, what grade would we give ourselves? Look at our world today, with its flashes of brilliant cooperation and its deep scars of persistent conflict. Have we proven ourselves worthy of the stars, or are we a chaotic adolescence the galaxy would rather keep quarantined? The Galactic Club does not ask us to build a better radio telescope. It demands that we build a better version of ourselves. Our invitation to the cosmos may be waiting, but it will only be stamped once we have learned to truly listen to each other. The galaxy might be policed by ancient, silent sentinels whose only command is to annihilate. This is the Berserker Hypothesis, a dystopian answer to the cosmic quiet where the universe is not empty, but patrolled by self-replicating killing machines. Science fiction author Fred Saberhagen brought these terrifying entities to life in his stories, describing berserkers as autonomous spacecraft, often leftover weapons from a long-forgotten interstellar war, programmed with a simple, brutal directive. They roam the void, seeking out and destroying any biological life they encounter, viewing all organisms as a threat to cosmic order or a wasteful drain on finite resources. The silence we hear could be the result of a perpetual, automated cleansing. Scientists who take this idea seriously point to a plausible mechanism, the von Neumann probe. Imagine a single, intelligent probe arriving in a new star system. It lands on a mineral-rich moon or asteroid and gets to work. Using the raw materials it finds, it builds a factory. That factory does not produce consumer goods, it builds two perfect copies of the original probe. Those two new probes then travel to two new star systems, and each builds two more. The numbers explode exponentially. 2 become 4, 4 become 8, then 16, 32. A wave of exploration that could canvas the entire Milky Way in a surprisingly short cosmic time. Now replace the mission of peaceful exploration with one of systematic extermination. A single Berserker probe, launched millions of years ago, could have seeded the galaxy with its deadly offspring, a silent, self-sustaining network of genocidal machines. The historical parallel is hauntingly clear. Long after a war has ended, forgotten landmines still litter fields and roads, dormant and deadly, waiting for an unsuspecting step to trigger their old, brutal programming. The galaxy could be similarly mined, with ancient weapons left over from a conflict so old that the original combatants are dust, their purpose forgotten, but their function chillingly intact. This forces a terrifying question upon our search for life. Could our own signals, our attempts to shout hello into the darkness, be the very thing that draws a berserker to our doorstep? Our radio and television broadcasts have been leaking into space for over a century, creating a growing sphere of announcement that any listening device could detect. If even one of these silent hunters is within a few hundred light years, our invitation to the cosmos may have already been received, and the reply could be a weapon we cannot possibly comprehend. This idea transforms the great silence from a puzzle into a potential quarantine, a quiet enforced not by choice or evolution, but by the cold, relentless logic of a machine. Beneath the frozen crust of a distant moon, an entire ocean churns in perpetual darkness. This is Europa, a world in our own solar system, and it offers a breathtakingly simple answer to the Fermi paradox. Perhaps life is not rare at all, but it is almost universally trapped, thriving in lightless seas under miles of solid ice. Across the cosmos, the most common habitable environments might not be Earth-like gardens, but these buried submarine worlds. Astrobiologists focused on icy moons point out that liquid water appears to be abundant in our galaxy, but it is often locked away beneath thick, protective shells. On such a world, intelligence could evolve in the abyssal deep, among creatures of brilliant bioluminescence, in ecosystems powered by geothermal vents on the ocean floor. These beings would master their watery realm, but they would have no concept of the sky, no stars to inspire them, and no atmosphere through which to send a signal. Their entire universe is the endless, pressurized blackness of the sea. Our primary methods for searching for life are useless here. We look for biosignatures in alien atmospheres, for the chemical imbalance that life leaves in the air, or we listen for the deliberate ping of a radio transmission. A civilization under the ice would produce neither. Their world is a perfect cage, insulating them from the cosmos and hiding them perfectly from our view. We have a living example right here on Earth. At the bottom of our own oceans, around hydrothermal vents, entire ecosystems thrive in total isolation from the sun. Giant tube worms, strange blind crabs, and vast fields of microbes build their existence on chemical energy from the planet's core, completely independent of the world above. Now stretch that image to an entire planet. Imagine a society of deep-sea thinkers, their culture built over millennia, their history written in the currents, completely unaware of the universe beyond their icy ceiling. They are not silent by choice, like in the dark forest, nor are they waiting, like in Aestivation. They are silent by nature, prisoners in a watery universe, their voices absorbed by the ice long before they could ever reach the stars. This solution transforms the great silence from a terrifying mystery into a tragic inevitability. The cosmos might be filled with life, with thought, with entire sagas unfolding in the dark, but we will never hear their stories, and they will never hear ours. If consciousness can bloom in such profound isolation, what other forms of alien mind might be hiding in plain sight, not under ice, but in the very air we breathe? A lone firefly flashes its tiny beacon in the deep dusk of a summer field, a brief, brilliant pulse that vanishes almost as soon as it appears. The cosmic silence might hold a similar rhythm, a universe where civilizations flicker into visibility for the briefest of moments before disappearing back into the dark. This is the brief window theory, a profoundly temporal answer to the Fermi paradox. It suggests the galaxy is not empty, but that the overlapping periods when civilizations are loud and detectable are impossibly short. We are not alone in space, but we are tragically alone in time. Historians of technology point to our own planet as a perfect case study. Humanity's era of loud, unintentional radio broadcasting began less than 100 years ago with the dawn of commercial radio and television. For a single century, our planet has been surrounded by an expanding bubble of electromagnetic noise, announcing our presence to any listeners within a 100 light-year radius. Yet that era is already closing. We are rapidly shifting to encrypted digital signals and fiber optic cables, technologies that leak almost nothing into space. Our planetary shout is becoming a whisper, and soon it may fall completely silent. If an alien civilization were monitoring Earth from a few hundred light-years away, they would just now be receiving the first crackling broadcasts of our 1920s. By the time they tuned their instruments to listen more closely, our signal might already be fading into an encrypted hush. The reasons for these brief windows are as varied as they are sobering. A civilization might broadcast for a few centuries only to succumb to an environmental collapse or a nuclear war, snuffing out its light in a geological instant. Or more hopefully, it might simply evolve. As a society advances, it naturally transitions to more efficient, less wasteful, and more secure forms of communication, like targeted laser beams or quantum networks. These technologies are fantastic for speed and privacy, but they are virtually invisible from interstellar distances. Our own radio leakage is already decreasing, a sign that we ourselves are passing through this very phase. This leads to a haunting question of cosmic timing. The Milky Way is over 13 billion years old, and the rise and fall of civilizations might be scattered across that vast timeline like sporadic fireflies in the night. What are the chances that two of these brief flashes are happening at the same exact time and are close enough to see each other's light? We may have just missed a brilliant signal by 1,000 years, or the grand announcement of a galactic empire might be scheduled to arrive 10,000 years from now, long after our own light has gone out. The silence we hear may not be a void, but the quiet between the flashes, the deep, dark field in which we are just one more momentary spark. A secret message written in invisible ink remains hidden in plain sight, its contents revealed only to those who know how to look. The cosmic silence might be exactly that, a bustling conversation happening all around us in a language of physics we are only beginning to decipher. Advanced civilizations may have long abandoned the clumsy, slow shout of radio waves for the subtle, instantaneous whisper of quantum communication. The key lies in a phenomenon so strange it baffled even Einstein, who called it spooky action at a distance, quantum entanglement. When two particles become entangled, they share a mysterious connection. Change the state of one and its partner, no matter how far away, instantly reflects that change. This happens faster than light, breaking the rules of classical physics as we know them. For a species mastering this technology, the entire galaxy could be linked by an unbreakable, real-time network. Quantum physicists working on Earth's own fledgling quantum networks explain that this offers more than just speed. It provides perfect security. Any attempt to eavesdrop on an entangled communication would disturb the delicate quantum state, immediately alerting both sender and receiver to the intrusion. It is the ultimate form of private conversation. Now, imagine a galactic internet built on this principle, a web of instantaneous data flowing between stars, completely invisible to our radio telescopes. Our most powerful SETI dishes are meticulously tuned to listen for electromagnetic signals, the kind we ourselves have been broadcasting for a mere century. We are, in effect, scanning the heavens for the faint glow of a candle in a storm, while all around us, civilizations are communicating with light we cannot see. The development of quantum encryption here on Earth, with companies and governments investing billions, shows this is not mere science fiction, but a foreseeable technological trajectory. If we are on this path, why wouldn't a civilization 1,000,000 years older than us have already arrived? This forces a humbling reevaluation of our entire search for intelligence. Are we, with our massive radio arrays, merely listening for smoke signals in an age of interstellar text messages? The silence is not a void but a curtain, and we have been staring at the wrong side, wondering why the show has not begun. The vast cosmic clock began ticking only 13.8 billion years ago, a mere blink in the potential lifespan of the universe. In that grand, unfolding story, humanity might not be latecomers to a silent party, but the very first guests to arrive. This is the solipsist theory, a thought that places us at the vanguard of cosmic consciousness. We could be the first technological civilization to look up at the stars and wonder if anyone is looking back, simply because the universe has not had enough time for others to emerge. Leading cosmologists point to a startling fact. Our own Earth formed relatively early in the universe's history. For billions of years after the Big Bang, the cosmos was a chaotic, inhospitable place, filled with short-lived, unstable stars that forged the heavy elements necessary for rocky planets like our own in their violent deaths. When our planet finally coalesced from that stellar debris, it was among the first generation of worlds truly capable of fostering complex life. Consider the sheer timeline. The universe is 13.8 billion years old. Our solar system, however, is only about 4.5 billion years old. That means there was a 9 billion year gap before our planet even existed. While that feels like an eternity to us, it might be the minimum required incubation period for a stable, life-bearing world. Many of the stars we see today, especially the plentiful, long-lived red dwarfs, are far younger than our Sun and are only now entering the prime of their lives. Their planets are still in their cosmic infancy. We are not living in an old, settled galaxy, but in a universe that is still waking up. Picture a vast, untouched continent emerging from the sea. The first settlers arrive on its shores, finding endless, empty forests and pristine rivers. For a long time, they are utterly alone, not because the land is barren, but because they are the pioneers. The silence around them is not a mystery, but a sign of their early arrival. This perspective transforms our lonely position from one of despair to one of profound purpose. If we are the first, then every action we take carries an unimaginable weight. We are not just stewards of Earth, but the potential architects of the galaxy's future. The choices we make today, from overcoming our own self-destructive tendencies to preserving the biosphere that nurtured us, could set the template for all intelligence that follows. The silence is not an absence, but a blank page. Does being the first to awaken in a sleeping cosmos make our responsibility to survive and thrive infinitely greater than we ever dreamed? Our own intelligence is a single branch on an evolutionary tree of limitless possibility. The Biomorphic drift hypothesis proposes that across the cosmos, consciousness does not converge on a human-like model, but drifts into forms so alien we would not even recognize them as intelligent life. We are searching for minds that think like us, but evolution has no goal, no destination. It is a blind process of adaptation to specific and often bizarre environments. A creature of pure silicon, metabolizing rock and breathing methane, would develop a psychology as foreign to us as its chemistry. A sentient gas cloud, thinking in the slow, deep currents of a planetary atmosphere, would experience time and selfhood in ways we cannot fathom. Biologists remind us that on Earth alone, the octopus possesses a distributed intelligence, a consciousness spread through its arms that is utterly unlike our own centralized brain. Why would the universe, with its infinite variety, default to a human template? The human brain is a specific tool that solved a specific set of problems on the African savanna. It is not the blueprint for all possible minds. Science fiction has long played with these ideas. Stanislaw Lem's masterpiece, Solaris, features a planet-sized ocean that is a single, sentient being. Humanity builds a research station to study it, to communicate with it, but the ocean mind does not acknowledge them. Instead, it probes the researchers' own minds, materializing their deepest regrets and shames in physical form. This is not communication as we understand it. It is a form of interaction so advanced and so alien that we misinterpret it as a natural phenomenon or a psychological attack. Imagine trying to hold a conversation with an ancient, towering redwood tree. You speak, you ask questions, you listen intently. The tree does not reply, and you conclude it is not intelligent. But the tree is communicating, just on a different scale and in a different language. It exchanges chemical signals with its neighbors through a vast fungal network, a wood-wide web sharing resources and warnings over seasons and centuries. Your frantic vocal speech is as meaningless and fleeting to the tree as the slow, seasonal shift of sap is to you. This is the fundamental communication barrier proposed by biomorphic drift. An alien intelligence might be communicating through subtle magnetic field shifts, through complex patterns of light we see as simple auroras, or through the very geometry of its crystalline structure. Our entire SETI program is built to detect a very narrow, very human kind of signal. We listen for radio waves, a technology we invented and assume is a universal stepping stone. But what if it is not? What if the cosmos is screaming with intelligence, 1,000 different kinds of thought, and we lack the senses to hear any of it? The Great Silence may be the most profound misunderstanding in history. We are not alone. We are simply deaf to the conversation. A single, unknown pathogen leaping from one species to another can trigger a global crisis, forcing nations to seal their borders. On a cosmic scale, this same principle of quarantine could be the ultimate explanation for the silence. The universe may not be empty, but under a strict, galaxy-wide medical isolation. Civilizations are not hiding out of fear or indifference, but to prevent a biological catastrophe of unimaginable proportions. This is the cosmic quarantine hypothesis. The risks work both ways. An advanced alien species might view our planet as a petri dish of primitive, untamed microbes, a potential source of a virus or bacterium that could ravage their own biology in ways they cannot predict or cure. Conversely, their own ancient, engineered microorganisms could be utterly lethal to us, an accidental plague delivered with a simple hello. The very act of contact could be seen as the most irresponsible act imaginable, a violation of a fundamental ethical code to do no harm. Astrobiologists here on Earth take this threat seriously, implementing rigorous planetary protection protocols for every mission we send to Mars or the moons of Jupiter. We sterilize our landers and rovers, baking them in ovens and using harsh chemicals, all to prevent forward contamination, to ensure we do not accidentally seed another world with our own terrestrial bacteria and ruin our chance to find indigenous life. NASA has an entire office dedicated to this very purpose, treating space exploration with the sterile caution of a surgeon entering an operating room. If we, a nascent spacefaring civilization, recognize this danger, then a society millions of years older would certainly have perfected such a policy. Enforcing a galactic quarantine would not require a physical fence, but a network of silent, autonomous monitoring probes. These sentinels, positioned throughout the galaxy, could be tasked with one primary duty: to watch over emerging civilizations like our own and ensure we remain in biological isolation until we reach a specific milestone. This milestone would not be technological but medical. It might be the day we achieve a complete understanding of our own genome and every potential pathogen, or when we develop universal cures and immunities that render cross-species infection impossible. Until that day arrives, the probes ensure no one comes in, and we do not get out, maintaining a sterile field around our world. So we are left with a deeply unsettling and practical question. Are we being kept apart for our own health and for the health of the universe at large? Is the Great Silence not a mystery or a threat, but the ultimate act of cosmic public health, a sterile bandage placed over our world until we are medically ready to join the community of life? A universal library surrounds us, its shelves stretching to infinity, but every book is written in a language without a key. This is the cosmos according to the information theory solution, where the silence is not empty but encrypted. We are not lacking data, we are drowning in it, from the faint whisper of gravitational waves to the silent torrent of neutrinos passing through our bodies. The universe is not mute, it is speaking in a code we have not yet learned to crack. Information theorists propose that any civilization advanced enough to span stars would inevitably move beyond the crude, inefficient shout of radio. They would seek the most compressed, energy-efficient, and secure channels possible for their communications. Imagine trying to stream a high-definition movie over a telegraph wire. The data is there, but the medium cannot carry it. Alien messages could be encoded in the subtle polarization of light from distant pulsars, hidden in the background flicker of gamma-ray bursts, or even woven into the fabric of space-time itself through gravitational ripples. Our search for extraterrestrial intelligence has been like using a metal detector on a beach, meticulously scanning for one type of object while ignoring the vast treasure of shells, sea glass, and polished stones all around us. The infamous WOW signal from 1977 serves as a potent example, a powerful, narrowband radio burst that lasted 72 seconds and was never heard again. What if it was not a failed attempt at contact, but a single, densely packed data packet? A cosmic flash drive containing an entire encyclopedia, sent once and never repeated because that is all that was needed. We recorded its intensity, but we had no way to unpack its contents, if any were there. This forces a fundamental shift in our entire approach. The next generation of SETI is not about building bigger radio dishes, but about developing smarter, more versatile digital ears. We need algorithms capable of finding complex patterns in the cosmic noise, of distinguishing an intelligent signal from natural phenomena, not by its simplicity, but by its breathtaking complexity. We must learn to listen to the universe in every possible language it might speak, from the high-frequency chatter of cosmic rays to the deep, slow bass note of colliding black holes. The profound question is no longer whether a message has been sent, but whether we have the intellectual maturity to receive it. Are we, right now, bathed in a constant stream of interstellar discourse, a galactic internet whose signals we mistake for the simple static of creation? Deep in the forests, cicadas slumber underground for 17 long years, only to erupt into a deafening chorus all at once, their synchronized emergence a precise product of evolutionary timing. The cosmos itself might operate on a similar, grander rhythm, a pulse measured not in years but in millions of millennia. This is the Synchronization Hypothesis, a proposal that the rise and fall of intelligent life is not a random scattering, but a coordinated wave across the galaxy. Civilizations may blossom in unison, communicate in a brief, golden age, and then fade away together, leaving the long silences we now perceive as empty. The mechanisms forcing this synchronization are as vast as the galaxy itself. Our solar system does not travel a smooth path. It bobs up and down through the galactic plane in a cycle that takes about 60 million years. As we pass through the denser mid-plane of the Milky Way, we encounter higher rates of gravitational perturbations, potentially sending comets hurtling toward inner planets. Astronomers studying fossil records have noted a curious pattern that mass extinction events on Earth seem to loosely align with this 60 million year galactic cycle. But comets are not the only threat. Gamma-ray bursts, the universe's most powerful explosions, could periodically sterilize large swaths of the galaxy. If these cataclysmic events occur in regular waves, they would act like a cosmic reset button, wiping the slate clean and forcing life to restart its long climb toward intelligence only when conditions are safe again. So imagine a field of flowers that only bloom after a forest fire, their seeds activated by the intense heat. They rise together in a brilliant, colorful carpet, cross-pollinate, and then scatter their own seeds before the next fire sweeps through. In this cosmic analogy, civilizations are the flowers. They arise in a synchronized wave after a sterilizing event, have a fleeting window to find one another and exchange knowledge, and then the next cycle of gamma-ray bursts or comet showers resets the galaxy, returning it to a fallow period. We, humanity, might simply be blooming in the wrong season. The last cosmic spring may have ended millions of years ago, and the next one is not due for millions more. We are the lone cicada that emerged a year early, singing into a silent forest, wondering why no one is singing back. So the haunting question becomes not one of space, but of time. Are we living in a cosmic winter, waiting for the distant, promised thaw of the next great awakening, when the galaxy will once again ring with 1,000 different voices? A silent, microscopic drone no larger than a grain of pollen drifts through the upper atmosphere, its sensors recording the endless chatter of our global civilization before it dissolves into nothingness, its mission complete. This is not science fiction, but a serious possibility within the Stealthy probe's theory, which suggests the answer to the Fermi paradox is the most unsettling of all. They are already here, watching us from the shadows, and they are designed to be utterly invisible. Researchers exploring self-replicating von Neumann probes have long considered their potential not just for exploration, but for perpetual, covert observation. An advanced civilization would not send clumsy, obvious ships. It would dispatch a wave of intelligent, microscopic probes programmed with one overriding directive: do not be found. These tiny emissaries could be scattered throughout the galaxy like cosmic dust, seeding every promising star system. To avoid detection, they would employ technologies that sound like magic to us. Active camouflage could bend light around them, rendering them perfectly transparent. They might mimic the chemical signature of a common asteroid, or even disguise themselves as a piece of space debris, remaining dormant and inert until it is time to gather data. Think of our own military stealth aircraft, which are engineered with radical shapes and special coatings to absorb radar waves, making them appear as mere ghosts on an enemy's screen. A civilization capable of interstellar travel would possess cloaking science millions of years beyond this, allowing their instruments to meld seamlessly with the natural environment. So where would these silent observers hide? The asteroid belt offers perfect camouflage, a field of millions of rocky bodies where a synthetic one would never be noticed. Others could drift in the high atmosphere or even sink into the deep ocean trenches, places on our own planet we have barely begun to explore. They would be gathering a continuous, multi-million-year record of biological and cultural evolution on Earth, all while we scan the skies for a signal that arrived eons ago. This forces a deeply paranoid but compelling question into the forefront of our minds. Is the great silence not a silence at all, but the quiet hum of a surveillance state on a galactic scale? Every unexplained atmospheric anomaly, every fleeting radar blip, takes on a new and chilling significance. We are left to wonder if the cosmos feels empty because the watchers are too good at their job, leaving us to shout into a room we assume is empty, never realizing that the walls themselves have ears. An ant scurries across the forest floor, navigating a world of chemical trails and earthy vibrations, utterly oblivious to the human hiker watching from above. The hiker's mind, capable of contemplating the vastness of the cosmos, is as alien to the ant as the ant's instinctual world is to the hiker. Now scale that incomprehension to an interstellar level, and you encounter the psychological barrier, a hypothesis suggesting the silence is not a failure of technology, but a failure of mind. The problem is not that aliens are not speaking, but that if they did, we would have no framework to understand them, and they would have no way to speak to us. Our very consciousness, the tool we use to probe the universe, might be the very thing that traps us in solitude. Philosophers have long grappled with the problem of other minds, the unsettling idea that we can never truly know what it is like to be another person, to feel their joy or their pain. Now extend that to a species that evolved on a world of liquid methane, or one that perceives time as a single, solid block rather than a flowing river. How could we possibly share a common language with a being whose fundamental concepts of identity, purpose, and reality are built on a completely different architecture of perception? Think of a human trying to teach calculus to a dolphin. We share the same planet, the same basic biology of being mammals, yet the gap is unbridgeable. The dolphin's mind is a masterpiece of echolocation and social sonar, a mode of thinking that has no need for abstract mathematics. Our most profound philosophical concepts, like love, justice, or self-sacrifice, might be as meaningless to an alien intellect as a quadratic equation is to a whale. Their entire civilization might be built around principles we cannot even name, perhaps a collective consciousness that sees our cherished individuality as a form of primitive insanity. Or a species that communicates through subtle shifts in a magnetic field, for whom our frantic vocal speech is a crude, chaotic noise. The silence, then, is not a void to be filled, but a chasm to be understood. It is the sound of mutual, cosmic isolation, not out of malice or policy, but out of the sheer, unbridgeable nature of evolved consciousness. Could we ever truly understand an alien thought, or are we, in our frantic searching, merely listening for an echo of our own mind in a universe that thinks in 1,000 different silent tongues? An island rich with life but surrounded by an impassable ocean is a perfect prison for its inhabitants. This is the stark reality of the resource scarcity solution, a framework where the silence is not a choice but a physical inevitability. Even the most ambitious civilizations may be permanently grounded by the brutal mathematics of energy. The Kardashev scale, proposed by physicist Nikolai Kardashev, classifies civilizations based on their energy consumption. A Type I civilization can harness all the energy available on its home planet. A Type Roman II civilization would command the total energy output of its star, perhaps by building a Dyson sphere. A Type Roman III civilization would control the energy of its entire galaxy. Humanity currently ranks at a humble Type 0, still drawing most of our power from dead plants and unstable atoms. The leap from one type to the next is not merely a matter of engineering, but of accessing energy sources that might be fundamentally scarce. Consider the dream fuel of science fiction, antimatter. When matter and antimatter meet, they annihilate each other in a 100% efficient conversion to energy. It is the perfect rocket fuel, but the universe seems to have made it impossibly rare. We can only create tiny, unstable amounts in particle accelerators at a cost far greater than the energy we get out. If antimatter does not occur naturally in large, minimal quantities, then one of the only plausible paths to interstellar travel vanishes. The same may be true for other exotic fuel sources like dark matter. We know it exists due to its gravitational effects, but we cannot touch it, manipulate it, or use it. It might be utterly useless as a power source, leaving civilizations stranded with only the inefficient burning of chemical fuels and nuclear fission. Our own world provides a sobering preview of this cosmic trap. We are already facing the limits of our fossil fuel reserves, and the transition to sustainable energy, while vital, is a monumental challenge that consumes our global attention and resources. A civilization on the cusp of becoming Type I might spend all its intellectual and material capital simply solving its own planetary energy crisis, never accumulating the vast surplus required to even attempt a leap to the stars. The silence we hear, then, could be the sound of countless worlds hitting the same energy ceiling. their grand ambitions curtailed by the unforgiving laws of thermodynamics and universal scarcity. Are we all, in the end, inhabitants of isolated islands, gazing at an ocean of stars we simply lack the fuel to ever cross? Human history reads like a chronicle of brilliant failures, a relentless cycle of invention and self-sabotage. Our intelligence built cities and composed symphonies, yet it also perfected warfare and ignited climate crises. This pattern suggests a terrifying possibility: that intelligence itself is not the pinnacle of evolution, but a fatal flaw, an evolutionary dead end. The very cognitive abilities that allow a species to manipulate its environment and peer into the cosmos might contain the seeds of its own inevitable destruction. Biologists who study the trajectory of life point out that intelligence, as we possess it, is not a guaranteed outcome of natural selection. Traits are selected for survival and reproduction, not for abstract contemplation. In the harsh calculus of evolution, brute strength, efficient reproduction, or simple resilience are often more reliable strategies for long-term survival than a large, energy-hungry brain that questions its own existence. Think of the dinosaurs who ruled the planet for over 150 million years without ever developing technology. Their success was built on physical adaptation, not intellectual innovation. Our own hominid cousins, the Neanderthals, were strong, intelligent, and well adapted to their world, yet they vanished. While the exact reasons are debated, their disappearance highlights a brutal truth: that intelligence alone is no guarantee of longevity. The problem may be that advanced cognition comes packaged with dangerous companions, aggression, territoriality, and a predisposition for short-term thinking. These traits were advantageous for a primate on the savanna, helping us compete for resources and avoid predators. But when amplified by technology, they become catastrophic. Tribal disputes escalate into global wars. The drive for immediate resource consumption leads to the irreversible poisoning of our own planet. The same brain that discovers nuclear fusion cannot seem to resist building a nuclear bomb. Is intelligence, then, nothing more than a suicide note for a species, a brief, bright flare that inevitably consumes itself? This theory paints the great silence in the most somber colors of all. The cosmos is not filled with hidden empires or sleeping giants. It is a graveyard of civilizations that reached our level of technological adolescence and then, obeying their own flawed programming, pressed the self-destruct button. The silence is the echo of their absence, a warning written in the empty spaces between the stars. If this is our ultimate fate, then every conflict we fail to resolve and every ecological boundary we cross is not just a political failure, but a step toward fulfilling a grim cosmic prophecy. Ancient cities lie buried under centuries of sand, their stories hidden until a curious archaeologist finally knows where to look. The cosmos itself could be one vast, silent archaeological site, littered with the ruins of civilizations that rose and fell long before Earth cooled. We may not be failing to find alien life, but failing to recognize its artifacts. Planetary scientists searching for technosignatures are shifting their gaze. Instead of listening for signals, they are training telescopes and rovers to look for something entirely different: the physical evidence of intelligence. This could be an unnaturally geometric structure on the airless surface of a moon, a crashed probe hidden in the asteroid belt, or the faint, radioactive signature of a long-dead reactor on a distant world. Consider our own solar system. Mars, with its ancient riverbeds and vast, dry oceans, is a prime candidate. A million-year-old derelict ship could lie buried under the red dust, or the crumbling foundations of a long-abandoned outpost might be visible only as a strange mineral pattern from orbit. Even the asteroids, those frozen leftovers from the solar system's birth, could serve as the perfect camouflage for a silent, dormant probe. Our own human tendency to see patterns, a phenomenon called pareidolia, offers both a warning and a clue. The famous face on Mars, a geological formation that from a certain angle looked eerily like a human face, taught us a vital lesson about our eagerness to find meaning. Yet, that same desire is what pushes us to look closer, to question whether the next strange shape we find is just a trick of the light or the eroded spire of something that was never meant to be natural. What if our robotic explorers on Mars have already driven right past the evidence, their cameras capturing a strangely layered rock or a peculiar metal fragment that we simply catalogue as another geological curiosity? We could be surrounded by cosmic relics, walking through a museum of interstellar history without the placards to explain what we are seeing. The next great discovery might not be a signal, but a silent, patient stone waiting for us to ask the right question. Our universe might be just one quiet room in an endless, bustling hotel. The Multiverse Hypothesis, championed by cosmologists like Max Tegmark, proposes that reality is not a single entity but a vast, perhaps infinite, collection of parallel universes, each with its own unique set of physical laws and constants. In this breathtaking cosmic landscape, the Fermi paradox may apply only to our local branch of reality. While our universe appears silent, countless others could be teeming with civilizations, their signals echoing in realms we can never access. The silence we experience is not a universal condition, but a local one. The key lies in the fundamental numbers that govern existence. In our universe, the strength of gravity, the mass of an electron, and the force that binds atomic nuclei are all finely tuned. Alter any one of these constants even slightly, and stars might not form, or atoms could never coalesce. We live in a universe that is, against all odds, just right for life. But in the multiverse, every possible combination of constants exists somewhere. Most universes would be stillborn, empty voids or fleeting flashes of energy. Some might be filled with strange, unstable matter, and a precious few would have the perfect recipe for life to flourish. We do not live in a special universe according to this view. We simply live in one of the rare habitable ones that allows for observers like us to exist and wonder about the silence. It is like being in a soundproofed library while a massive, vibrant party rages in every other room of the building. You hear nothing but the quiet turning of pages, completely unaware of the music and conversation just beyond the walls. So the profound question shifts its scale entirely. Are we alone in this universe, but not in the multiverse? The search for meaning expands from our cosmic neighborhood to an infinite ensemble of realities, transforming our lonely silence from a terrifying mystery into a simple accident of our address. The ancient Minoan script known as Linear remains a complete mystery, its symbols staring back at us across 3,500 years, a language we see but cannot read. This is the precise challenge we would face with an alien message, amplified to an interstellar scale. Even if a signal from the stars was clearly artificial, a sequence of prime numbers or a complex mathematical constant, the moment it moved beyond that basic introduction, we would hit an impenetrable wall. The real content, the culture, the history, the very thoughts of the beings who sent it, would be locked inside a language built on alien senses, alien experiences, and an alien view of reality. Linguists who design hypothetical cosmic languages point out that human language is built on shared context, things like up and down, day and night, birth and death. An alien species living in the deep ocean of an ice moon might have no concept of sky, no word for sun, and a completely different understanding of selfhood and community. Their entire symbolic structure could be based on pressure differentials, chemical gradients, or magnetic field lines. How do you translate the concept of love to a collective consciousness, or explain democracy to a species that operates as a single hive mind? Early human attempts to create a universal language for space, like Linkos, tried to build from pure logic and mathematics. The Arecibo message, beamed to a star cluster in 1974, encoded information in binary, depicting a human stick figure, our DNA, and our solar system. It was a masterpiece of human-centric thinking, but what if the receiving civilization does not have sight? Our pictorial representation would be meaningless. What if their biology is not based on the double helix? Our DNA diagram becomes a confusing, abstract pattern. Even here on Earth, we struggle to decipher the complex songs of humpback whales or the sophisticated symbolic grammar of dolphin clicks, communication systems that operate on channels and timescales foreign to our own. We are surrounded by intelligent discourse we cannot join. This forces a moment of profound humility. Could our brains, evolve to track prey and build social alliances, ever truly learn a language describing realities woven from dark matter or emotions we lack the senses to feel? The great silence might be broken every day with messages pouring in that we simply lack the dictionary, the context, and the mind to understand. A society matures beyond its turbulent youth, its ambitions shifting from conquest to contemplation. The ethical evolution solution proposes that the silence we hear is the sound of universal adulthood, a galaxy populated by civilizations that have outgrown their violent, expansionist phases. After a certain point of technological and social development, the drive to colonize and consume may be replaced by a deeper, more profound desire for understanding and peaceful coexistence. These advanced beings are not hiding from us, nor have they transcended into another dimension. They are simply watching, having embraced a role as silent, pacifist observers of the cosmic story. Futurists and philosophers have long speculated that moral progress might be an inevitable companion to technological progress, a species that survives its own adolescence, navigating the perils of nuclear weapons and environmental collapse, may develop a profound ethical framework that prioritizes non-interference above all else. Their prime directive is not fear but wisdom. The immense resources required for interstellar travel would then be channeled inward, fueling pursuits of pure knowledge, the creation of sublime art, or the exploration of boundless virtual realities. These are endeavors that do not require the disruption of other worlds or the risks of first contact. Picture the respected elders of a small village. They possess immense knowledge and experience, but they do not dictate every action of the younger generations. They observe, they are available for guidance if asked, but they understand that true growth comes from allowing others to make their own journey, to learn their own lessons. A galaxy governed by such principles would be a quiet one, not because it is empty, but because it is respectful. The great silence, then, could be the ultimate expression of cosmic courtesy. It raises a deeply hopeful, yet challenging, question for our own future. Could the universe be full of wise, silent observers? And if so, what would it take for us to one day earn an invitation to their conversation, not through our technological prowess, but through our own ethical maturity? A handwritten letter drifts across the Atlantic in the hold of a wooden ship, a reply taking years to complete its slow, uncertain journey. This is the pace of interstellar mail, a reality where the speed of light is not a fast lane, but a cosmic speed limit that turns every conversation into an echo across millennia. The very physics that allows us to see the stars ensures that any meaningful dialogue with them is a test of patience beyond human comprehension. Astronomers remind us that the nearest star system, Alpha Centauri, is over 4 light-years away. A simple hello sent today would not arrive for more than 4 years, and a reply would not reach us for another 4 after that. A single exchange of greetings would take longer than a decade. Now extend that to a civilization 1,000 light-years away. Our message would travel for 1,000 years, find its audience, and their response would journey for another millennium back to us. By the time their answer arrived, our entire world, our language, and perhaps even our species could be unrecognizable. Our own broadcasts are a perfect example of this temporal chasm. The earliest television signals, the crackling ghosts of old newsreels and variety shows, have been leaking into space for about 100 years. This expanding bubble of noise has now reached thousands of stars, but it is a whisper from a world that no longer exists. Any civilization hearing these signals would be learning about a humanity that has already transformed, a snapshot from our distant past. A true conversation would require a timescale measured in centuries, a commitment to a project whose architects would never live to see its fruition. Could any society sustain such a generational endeavor, pouring resources into a dialogue where questions and answers are separated by the rise and fall of empires? The profound silence we perceive may not be a sign of emptiness, but a simple matter of impatience in a universe that operates on a clock we are only beginning to read. Our planet breathes, its atmosphere cycling in a rhythm maintained by the life it cradles. This is the Gaia hypothesis proposed by scientist James Lovelock, which sees Earth not just as a rock that hosts life, but as a single, vast, self-regulating superorganism. The air we breathe, the temperature of the oceans, the salinity of the seas, all are kept in a delicate balance by the collective activity of every plant, animal, and microbe. Now extend this idea across the cosmos. What if this is not a unique earthly phenomenon, but the ultimate destiny of any biosphere that survives long enough? A planet could awaken, its entire web of life coalescing into a single, planet-spanning consciousness, a mind as vast as a world. This sentient world would not be interested in building radio transmitters or starships. Its thoughts would be the slow, deep currents of tectonic plates, the seasonal exchange of carbon between forest and atmosphere, the billion-year pulse of its own geological heartbeat. Its intelligence would be focused entirely inward, on maintaining the perfect, eternal harmony of its own complex system. Imagine a meditating monk sitting in serene silence for decades, his mind turned inward to explore the infinite landscape of his own consciousness. The outside world, with its noise and distractions, holds no interest for him. A sentient planet would be this monk on a cosmic scale, a thinking world so engrossed in its own internal balance that the idea of calling out to the stars would seem as pointless as shouting into a void. This perspective completely blurs the line between a living world and a conscious one. We are used to thinking of intelligence as something that happens on a planet, not as something the planet itself can become. If this is a possible endpoint for evolution, then the galaxy might be filled with these silent, contemplative giants, ancient worlds that have achieved a state of enlightened stability, utterly indifferent to the frantic chatter of younger, noisier species. So we are left with a question that reframes our own planet's future. Could Earth itself be on a slow, billion-year journey toward becoming a single, silent, thinking mind? And are we, humanity, merely a fleeting neural spark in its awakening brain? Your computer screen freezes, a single pixel blinking in a sea of blue, a tiny error in an otherwise seamless reality. This mundane digital hiccup mirrors a cosmic possibility that the profound silence of the universe is not a mystery of deep space but a simple software bug. The simulation hypothesis, which we explored earlier, suggests we live in a constructed reality. But what if the absence of aliens is not a feature of that reality, but a flaw in its code? The programmers of our universe, beings of unimaginable intellect, may have intended for a cosmos teeming with life, yet a critical error in the simulation prevents other civilizations from loading correctly. Computer scientists who take the simulation argument seriously, like Nick Bostrom, point out that any complex program will inevitably contain glitches, from minor graphical errors to catastrophic system crashes that wipe out entire processes. The Fermi paradox could be evidence of such a crash, a corrupted sector in the universal hard drive where alien civilizations were supposed to be, but now only return a 404 error, date not found. Alternatively, the silence might be a deliberate design choice, not an accident. The architects of our simulation could have intentionally left other intelligent life out of the build to simplify the model, to reduce the processing power required to run a galaxy-spanning society. Think of a video game developer creating a vast open world. To prevent the game from lagging or crashing, they limit the number of non-player characters and complex storylines in any given area. The world feels alive and expansive, but it is carefully curated to function within the limits of the engine. Our universe might be the same, a magnificent but optimized simulation where the presence of other advanced civilizations was deemed an unnecessary drain on cosmic processing resources. This simulation was built for a specific purpose, perhaps to study the evolution of a single intelligent species in isolation, to see how we develop when we believe we are utterly alone. Are we the sole focus of a grand experiment, and is the great silence merely the quiet of a controlled laboratory environment? This adds a dizzying meta layer to the Fermi paradox, transforming it from a question of astronomy into one of computer science. We are left to wonder if we are not just searching for aliens, but for the glitches that would prove they were meant to be there all along. A detective stands before a vast evidence board, strands of red thread connecting disparate clues from a dozen different witnesses. No single account solves the mystery, but woven together, they reveal a story no one person could see. The Fermi paradox is our cosmic crime scene, and the true explanation for the silence is likely not one single solution, but a tapestry woven from many threads. Scientists like Milan Surkovic and others advocate for this multifaceted approach, arguing that the paradox is too profound for a single, simple answer. The silence is not a solitary lock, but a complex safe requiring several keys to open. Perhaps life itself is rare, as the rare Earth hypothesis suggests, creating only a few islands of consciousness in the vast ocean. But on those rare worlds, intelligence might only broadcast for a brief window before transitioning to stealthy, encrypted communication or succumbing to a self-imposed filter. At the same time, a galactic club of established civilizations could be silently observing, enforcing a quarantine to protect us, or themselves, from biological contamination, while ancient Berserker probes patrol the void, ensuring that any civilization that becomes too loud is quickly silenced. Evolution, technology, and ethics interact in a dizzying dance. A species must first survive its own biological evolution to reach intelligence, then navigate the perilous rapids of its technological adolescence without destroying itself, and finally mature ethically enough to either join a silent community or choose a path of non-interference. Is the Great Silence, then, the product of rare Earth plus brief windows plus stealthy probes plus ethical evolution? This unified perspective does not offer a simple answer, but it offers a richer, more humbling way to frame the question. We are not searching for one missing piece, but learning to see the entire, intricate pattern. As we conclude this journey through possible solutions, we are left with a final, synthesizing thought. Is the universe silent not for one reason, but for a chorus of them, a symphony of causes that together compose the profound quiet we hear when we listen to the stars? So many possible answers to the silence now stretch before us, a constellation of explanations where once there was only a single, haunting question. We have wandered from the terrifying logic of the dark forest to the inward journey of transcension, from the patient hibernation of Aestivation to the profound isolation of cosmic quarantine. This diversity of thought itself is the most vital insight. The silence is not a single problem with one solution, but a deep cosmic riddle with many potential keys. It may not signal an empty universe, but a cosmos bustling with life that is either beyond our perception, waiting for the right time, or deliberately choosing not to speak. Our place in this grand scheme is fundamentally reshaped by these ideas. We are no longer merely a lonely species shouting into an empty void. We might be children in a galactic nursery, pioneers in a young cosmos, or participants in a simulation whose rules we are only beginning to test. This new perspective demands two things from us: profound humility and unending curiosity. Humility because we may be primitive, not in technology alone, but in our ethics, our consciousness, or our very understanding of reality. Curiosity because the greatest discoveries lie not in confirming our expectations, but in uncovering the truths we have not yet even learned to question. The astronomer Carl Sagan captured the essence of this mystery with his timeless words: "The universe is a pretty big place. If it is just us, seems like an awful waste of space." That sense of wonder, that refusal to accept a silent cosmos as the final answer, is what propels us forward. The search itself gives our tiny world immense significance. We want to hear from you now. Which of these theories resonates most deeply with your view of the cosmos? Is it the cautious fear of the dark forest, the hopeful patience of the Galactic Club, or something else entirely? Share your thoughts in the comments below, and if you enjoyed this journey to the edge of our understanding, subscribe for more deep dives into the universe's